Welcome to physics class. So we have Nomsa standing on the ground, and she throws a pencil case vertically upwards to Mekwe, and with initial speed. And Mekwe fails to catch it, and then moves upwards, and then when it comes down, Mekwe catches it. So this is the situation. That's the vertical height, and then that's the time there. And then we have that projection up to the balcony where it was caught, because it didn't come down to the ground, it caught it midway. And then that's the maximum height, that's VF is 0, and that's the time 1.4, and that is the time. Okay, so these two sections have equal time, so 0.6, 0.6 there. So we need to know from 0.6 to 1.4 how many minutes or how many seconds does it take. Now let's say define free fall. So free fall is any object in motion. So the object has to be in motion, and it has to be under the influence of gravity only, or under the influence of gravitational force only. So you can just use gravity, it's the same thing. So any object in motion under the influence of gravity only is under free fall. So time it took to reach the maximum there, 3.2. Our answer is 1.4 seconds, because VF there is 0. From there to there, the velocity gets to 0. So we need to know our initial velocity. So the time it takes for pencil case to get to 0, that's 1.4 seconds. And from there to there, how long is it going to take? Under the free fall, acceleration is 9.8. that's what they want, so it's downwards. Okay, so acceleration will always be downwards, irrespective of whether you choose downwards, positive or negative. So it's 9.8 meter per second squared downwards. And then we have there, so we have that the sequence like from 0.6 to 1.4, so it's 1.4 minus 0.6, that gives us 0.8. so that's 0.8, that distance. So 0.8 plus 1.4 is going to be 2.2. So that is good. That's the point of symmetry, so it's going to be 2.2 for that equal distance. And then that means that we're going to have 1.4 minus 0.6 seconds to give us 0.8 seconds. And then using the symmetry, point of symmetry, 1.4 plus 0.8, which is the point of symmetry there, to give us 2.2 seconds. And that's it. That's our answer for 3.2.3. And then we move on to 3.3. so use the equations and the information on the graph. Initial velocity, so let's come the initial velocity there, we don't know, but we know that from that part to that highest point, the final velocity is 0. And then we also know the time, which is 1.4 seconds. Then we write our data. Initial velocity unknown, up we take it as positive, and then final velocity is equals to initial velocity plus acceleration multiplied by time. So that gives us our final velocity 0, our initial velocity we don't know, our acceleration is negative 9.8, and then we know that change in t is 1.4 there when our final speed is 0, so it's 1.4. And then we have v final, we take that to the left, becomes positive, so it's going to be positive 9.8 multiplied by 1.4. and that, using a calculator, we have 9.8 multiplied by 1.4 gives us 13.72. so it's 13.72 meter per second, and that's our answer for 3.3.1. so we get the steps there. Step 1, we write what we know and we don't know. So we know that change in t is 1.4 seconds, and then we have v final there 0. So those are information we use. We choose our direction up as positive. 2, we substitute all the values of the equation. Step 3, we simplify, and that's our answer. And then 3.3.2, height of the pencil above the ground. So we need an equation that covers everything. Initial velocity, that's the one we've been calculating, that's 13.72. and then change in time, we know it's 2.2. that's the point there, 2.2. and then change in time is 2.2. and then we have change in y is equals to initial multiplied by change in t plus a half multiplied by gravitational acceleration multiplied by t squared. So we have 13.72. all of that multiplied by 2.2 plus half. Our g is negative 9.8 multiplied by time 2.2 squared. So we're going to use a calculator just by parts. So 13.72 multiplied by 2.2 gives us 30.184. So it's 30.184. and then we have so that's going to be negative. So we have multiplying everything, 2.2 squared multiplied by negative 9.8 divided by half, 23.7116, and summing up together we have 6.468. rounding off to 2 decimal points, we have 6.47 seconds, and that's our answer. So once again we have step 1 unknowns, step 3. Okay, so step 1 we write what we know and what we don't know. Step 2 we substitute the information. Step 3 we simplify, and then we get the answer. 7.4, let's say they want the graph for the acceleration. So the graph for acceleration will look like this. The vertical part is acceleration and the horizontal part is time. That's acceleration there. Unit, that's going to be meter per second squared. And then we have our point 0. And then we have this part which is negative, so that's going to be that part there, that's negative 9.8. that's our acceleration, and value of acceleration 9.8. and then the entire time of motion, and our time there is 2.2. so we're going to put 2.2 somewhere there. So that's going to be 2.2 seconds related to that acceleration throughout. What does the area under the acceleration time graph represent? Supposed to be 2 marks at least, but let's just calculate for proof. We have our length there, which is seconds, and then we have our length is length times height, breadth can be height. So our height there is going to be that part, that's our height, which is meter per second. So it's meter per second squared actually. So when you simplify that gets into that once, and then that means that it's m over s. So meter per second gives us change in velocity. So our change in velocity is our final answer. So that's it for this problem. So if you have any comment, please leave below, and don't forget to follow, subscribe, and this is your tutor Black Adam. And always remember that you need to first choose direction, and then next you have to make sure what you know and what you don't know. Thank you for watching.